I'm here to talk to you about an organic compound family called the alkyl halides. The alkyl halides are a group of compounds that include many common products like Freon and Teflon, and some more dangerous products like mustard gas and DDT. They are a compound of carbon and hydrogen, where one or more of the hydrogen atoms have been replaced by a halogen atom. Recall that a halogen is an element in the 17th column of the periodic table, have 7 valence electrons, and can easily make bonds with carbon. Naming organic halides is very similar to naming a substituted hydrocarbon. The halogen atom is an attachment to the parent chain, like a methyl or diethyl, and the halogen's INE ending is replaced with an O. For example, this molecule is called 2,4-difluorobutane, just as with naming aliphatic hydrocarbons. The numbers out front and the di prefix indicate the butane molecule made two hydrogen substitutions. Also, oftentimes X is used to represent an halogen atom when drawing a diagram. When a halogen atom bonds with a hydrocarbon chain or ring, it makes the molecule much more polar. This is because the CX bond is more polar than the CH bond and can more easily pull electrons from carbon atoms towards it. The increase in polarity causes the alkyl halide to have a higher melting and boiling point and be more readily soluble in polar solutions. Halogenation or addition reactions occur when alkenes and alkynes add hydrogen atoms to their double and triple bonds. When the bond breaks, 2 more spots for bonding around the molecule are created and are filled by halogen atoms. For example, ethane reacts with bromine to form 1,2-dibromoethane. A substitution reaction happens when a halogen replaces hydrogen in a molecule. This reaction usually requires the input of energy as heat or UV light, whereas a halogenation reaction may happen at room temperature. An example of a substitution reaction is when an ethane reacts with bromine to form 1-bromoethane and hydrobromic acid. The problem with this reaction is that it is impossible to control the amount that any given molecule will react, resulting in molecules with many different amounts of halogens bonded to the molecule. However, these different molecule types can be separated from each other by their melting and boiling points, since having more halogens makes the molecule more polar. The third type of reaction associated with alkyl halides is called an elimination reaction and is an organic reaction that results in the loss of a molecule from a large molecule. In all cases, this happens when an alkyl halide is reacted with an OH- ion. A hydrogen atom and the halogen atom are taken from the chain to form water and the halogen, and the chain makes a double bond with the lone electrons. For example, 2-bromopropane reacts with a hydroxide ion to form propene, water, and a bromide ion. This type of reaction is commonly used to refine alkyl halide into a hydrocarbon. A deadly example of this reaction type is in mustard gas, where the gas reacts with water in your lungs to form hydrochloric acid.